Hello, welcome to my channel. In this video, we are going to be taking a look at integration commonly found in physics. So, one of the integration that we usually encounter in physics is given below, the integral of x dy all over into bracket x squared plus y squared close brackets raised by 3 over 2. Now, this kind of integration finds application in a topic that has to do with the interaction between current and magnetic field. So when we solve a problem under that topic, sometimes we usually encounter this kind of integral. So to solve this integral, it is important for us to make an assumption because it's not easy to just solve directly. So it's important for us to make an assumption of this form that y equal to x tan theta. So this is the variable dy. We want to change this variable from y to theta, a new variable called theta. Now, we placed our x here because of this x. If here were to be 1 plus y squared, then here will be nothing, just 1. If here were to be a squared, here will be a. So, with this assumption, we can manipulate this one to substitute into this part. So, first of all, what we need is dy. So, let's differentiate this expression with respect to theta. So, we have dy equal to x sec squared theta d theta. When you integrate this one, you get sec squared theta. X here is a constant, so that's why we left it. Okay, so now that we have y and dy, we can substitute into this equation. And we have x, this is our x, this is our dy, which is x sec squared d theta. That's this. X squared remains. Y squared will be x squared tan squared theta raised by 3 over 2. Now, what you quickly notice is that this x and x will become x squared. X squared here is common, we can factorize, and we have x squared sec squared theta, x squared into bracket 1 plus tan squared theta. Now we can take this power 3 over 2 to meet this one, and this one to meet this one from the law of indices. And if we take this one to meet this one, it becomes 2 cancels 2. We have x raised by 3. Then everything here will be raised by 3 over 2. So we have x cubed into bracket this expression. We have x squared. So we can cancel this one out so that we'll be left with just ordinary x, right? Then we have sec squared. Now let's recall that cos squared plus sine squared theta equal to 1. Now we want to get an expression for 1 plus tan squared theta. If we divide both sides by cos squared theta, divide this one by cos squared theta, cos squared theta, cos squared theta. Here becomes 1 plus here becomes tan theta. Then here becomes 1 over cos squared theta, which is this, and 1 over cos is sec. So 1 over cos squared theta will be sec squared theta. So wherever we see 1 plus tan squared theta in this expression, we'll replace with sec squared theta. And that gives us x squared sec squared theta, x cubed sec squared theta, 3 over 2. So if this one takes care of this, you notice that this divided by 2, we cancel this, leaving sec cubed theta. So we have x squared sec squared theta d theta, x cubed sec cubed theta. Everything takes care of this. Everything takes care of this, leaving d theta all over x standing alone, then sec theta. And 1 over cos theta is same as sec squared theta. So this expression reduces to cos theta d theta all over x. Now, mind you, our x here is a constant, so we can take it out, and we are left with integral of cos theta d theta. So just because of this substitution that we made, we can see what it finally leads to, which is a simple integral of cos theta. So if you integrate cos theta, that gives us sine theta. So we have our integral form, integral expression equal to 1 over x sine theta plus c, which is a constant. But if you notice, we moved from dy to theta. So we do not expect to leave our answer in this form. What we can do is to convert this sine theta back to what? Dy format. So, but to do that, we recall from this our expression y equal to x tan theta, which is the expression we initially assumed. And if we rearrange this one, becomes tan theta equal to y all over x. Now, we can see our theta, which is this. We can quickly draw a triangle of this form, where our theta here can be replaced here, And if you notice, tan theta is y all over x. So tan theta is opposite all over adjacent. So if this one is a angle, we can assume that this side, which is opposite all over adjacent, here will be y and here will be x. We can find here by saying the square root of this, the square of this plus square of this, all square root will give us the value of this one, which is this. So at this point, since we are interested in finding sine theta, we just come here and say, what is our sine theta, which is opposite all over hypotenuse. And that gives us sine theta equal to y all over square root of x squared plus y squared. So at this point, we can see that wherever we see sine theta, we just replace with y all over square root of this. And that gives us our integral equal to y all over x square root of x squared plus y squared plus constant. Now, sometimes when you are solving this kind of problem, we can have the limits from this point to this point. And when you have your limit, you substitute into this expression and C will no longer be needed. I hope this helps. Please like, share, and subscribe. And also follow for more. Thank you.